In this lesson, we're going to be looking at systems of linear and quadratic equations. And if we look at these first two, this is just a regular old system of equations which we should know how to solve. We've got two methods for this. If I look at the first one, the method I'm going to use here is substitution because this first equation is already solved for y. So I'm going to plug that value in for y right here. So I've got 3 times y, which is actually the 2x minus 1, plus x equals 4. And now I distribute, that's a 6x minus 3 plus x equals 4. I combine like terms, that's 7x minus 3 equals 4. And then I finish solving. I add the 3. And then I divide by the 7. So I find out that x equals a 1. But I'm not done yet. Remember, systems of equations, I need the x and the y value. So I essentially come back up here and say, okay, I'm going to plug that 1 in for my x, so I have y equals 2 times 1 minus 1. And I'm solving for y here, which is pretty easy since this one's already solved for y, so y equals 1. So I get the ordered pair 1, 1. Right? That's my system of equations. I solve for x and y simultaneously. If I look at the next one, this is a good candidate for substitution as well because of that y value in the second equation. But it's also an even better candidate for elimination. Remember, elimination is when we add or subtract the two equations from one another to eliminate one of the variables. And if we look, the 2x and the negative 2x are already lined up to be eliminated. So I don't even have to multiply the equations by anything. So I add these up. The 2y plus y is a 3y. The x's eliminate. Over here, I get a 15. And now I solve for y. I divide each side by 3. So I find out that y equals 5. All right? And that initial step is a little bit easier. But now I have to solve for x here. So maybe I'll plug it into this first equation and say, all right, 2 times y, which is a 5, plus 2x equals a 6. That's going to be a 10 plus 2x equals 6. And now I have to subtract the 10 from each side. So I get 2x equals a negative 4. And then I divide by the 2. So I got to make sure that I solve for each variable. So now that's the order pair negative 2, 5, showing my x and my y value, solved for simultaneously. All right? That's the approach to system of equations that we've dealt with when we were doing linear systems. Now we're going to solve systems of linear and quadratic equations. And really, I'm just going to do the same thing. I'm going to use substitution or elimination. Typically for us, substitution is going to be the best way to go. Elimination tends to be very messy. Because we have an x squared and an x, we tend to not eliminate one of the variables, even though we think we are. Okay? So I would typically just stick to substitution on these. All right? Abandon elimination altogether. So for something like this one, they're each y equals something. So right away, I can see that y equals this thing. I'm going to plug that in for y in my second equation. All right? So my second equation was y equals a negative x plus 2. But instead of y, I'm going to plug in the x squared minus x minus 2. And now to solve this system of equations, I just have to solve for x. And since I have an x squared, this is a quadratic that I'm going to be solving for. I'm going to add this x to each side. This is going to be an x squared minus 2 equals 2. I would probably subtract the 2 from each side. So I would end up with x squared minus 4 equals 0. And I'm getting this set equal to the 0 because I'm going to solve this by factoring. X squared minus 4x, I can factor. That's a difference of squares. Factors into an x plus 2 and an x minus 2. And now I set each factor equal to 0. X plus 2 equals 0. X minus 2 equals 0. And I solve each. Here I subtract the 2 from each side. I find out that x equals a negative 2. Here I add the 2 to each side, and I find out that x equals a positive 2. And you might think that we're done, but we're not, because remember, this is a system, which means I need to solve for x and y. And so really, I need 2 ordered pairs here because I have 2 solutions for x. And I can plug this into either one. I'm going to take that second equation. It's typically easier to plug it into the linear equation. So I'm going to plug each of these in. So when I do the first one, that's going to give me y equals a negative 2 plus 2. which is a 2 plus 2, which is 4. So that gives me the ordered pair negative 2 comma 4 for my first answer. And then I also have to plug the other x value in here. So I have a negative, and then I plug the 2 in. That's a negative 2 plus 2, which is 0. So that's the ordered pair 2, 0. So I get 2 answers because it means that the parabola and the line cross at 2 different spots, which makes sense because that one of those is a curve. It can cross at 2 different spots. Okay? And we've identified them. If I look at the next one, again, I'm abandoning elimination. I'm going right to substitution here. These are each solved for y, so I'm going to take this y value right here. If y equals this, I'm going to plug it in for y in my second equation. So my second equation, instead of y equals 4 minus x, instead of y, I plug in the x squared minus 6x plus 10. And now I'm going to solve this. So here I'm going to add the x to each side. I'm getting everything gathered together. That's a minus 5x and a plus 10. And now I subtract the 4. So I've got an x squared minus 5x plus 6 equals 0. And then from here, I'm going to solve this, and I can either solve by factoring, completing the square of the quadratic formula. Always check factoring first, so I build a bridge. Two numbers that multiply to give me a positive 6, but add to a negative 5 are going to be a negative 3 and a negative 2. So now this is going to factor into an x minus 3 and an x minus 2. And now I can set each factor equal to 0, and I'll bring that up here in my next step. So x minus 3 equals 0, x minus 2 equals 0, and I solve each. And now I'm not done. I need y values to go with each of those x values. And again, I'm going to take it from the linear equation. I'm going to use this linear equation. It's always easier to plug into the linear equation. 4 minus x, my first x value is a 3. So when I subtract that, that gives me a 1. So it's the ordered pair 3, 1 for this first x value. And then I do the same thing with the next guy. That's going to be a 4 minus 2, which is a 2. So I get the ordered pair 2, 2. So my two solutions here are the 3, 1 and the 4, 2. And that's it. Okay, so again, we set them equal to each other. We use that substitution. Then we can solve the quadratic that it leaves us with. And just make sure once you have those x values, you plug them back in to get the y values that go with them. Okay? Last example here, just to do a quick word problem. If the attendance at two parks are modeled by the following equation, one of them is following a linear model, so attendance is just continuously going up, and the other one is following a quadratic model. The attendance started going up and then started going back down because this is a parabola that opens downwards. Okay, so those are the two models that we're following. And we want to know, when will the attendance at each park be the same? Okay, and keep in mind that there are 2 different days that this could happen. So what we want to do is we want to set these equal to each other. In other words, here's my y value. If y equals this, I'm going to plug that in for y right here. So that's going to be a 20x plus 124 equals the negative x squared plus 39x plus 64. And now from here, I can either subtract the 20x and then add the 24, or I can take this trinomial and bring it to the other side. And that's actually what I'm going to do here, just because I want to take care of this negative that's out front first, because I don't want to deal with a negative in front of my x squared. So that's x squared plus 20x plus 124. I'm also going to bring the 39x over, so I'm going to subtract that from each side. And you can probably handle doing this in one step, but I'm going to break it down into multiple steps just so it's nice and crystal clear what I'm doing here. The 20x minus the 39x is going to be a negative 19x. And then I'm going to subtract the 64 from each side. So I've got an x squared minus 19x. Here it looks like that gives me a 60, a positive 60, so plus 60. Equals 0. And now I want to solve this. This is a quadratic that I need to solve. I'm going to solve it. I'm going to attempt to solve it by factoring first. I always want to try factoring first because that's the easiest. I build a bridge, two numbers that multiply together to give me a positive 60, but add together to give me a negative 19. It's going to be a negative 4 and a negative 15. Okay? So this factors into the x minus 4 and the x minus 15. And now I set each factor equal to 0. I do the x minus 4 equals 0. I do the x minus 15 equals 0. And I solve each. Right? So here I'm adding the 4 to each side. That gives me x equals 4. Here I'm adding the 15 to each side. So I get x equals a 15. And now it's time to kind of finish this off and interpret the results. The 4 needs something to go with it. Again, I'm going to take the linear model, the y equals 20x plus 124, and that's what I'm going to use to plug these in. So I'm going to have y equals, that's an ugly looking y. Let me try again. 20 times the x value. The first x value I got was the 4. So that gives me an 80 plus 124, which is a 204. And then I'm also going to do the other value. I'm going to plug the 15 in. When I plug that 15 in, I have to do the 20 times 15, which is, let me think for just a moment, 300, I believe. And then I add these together. That's a 424. Okay, so my two answers are these ordered pairs, the 4, 204, and then the 15, 424. And it's important to be able to look at that and kind of interpret the results here. Since this is a word problem, let's think about what this means. Well, this means that on the 4th day, the attendance for each park is 224. And this one means that on the 15th day, the attendance at each park is 424. Okay, so that's what this is telling us. Depending on what kind of park, I mean, this could be measured in millions of people. 204 million, or maybe 204,000. We don't know because they didn't give us that kind of information. But be aware of what each of these things means. Okay.